Welcome to Brandon Debunks the World. So yeah, put on your swimmies because we're going to dive headfirst into the shallow end. Don't forget to like, share, subscribe, and visit us on Patreon so I can finally afford to use the shopping cart at Aldi. For several decades, very few mysteries have stood in the face of science, quite like the enigma of dark matter. To better understand what dark matter is, let's explain why it's needed in the modern astrophysics standard model. When astronomers look to other galaxies and observe their structures, although they may come in spiral or cluster among other varieties, they are a grouping of hundreds of billions of stars and trillions of planets. Yet even this is not enough mass to make these disks and spheres have the cohesion they do. So scientists came up with dark matter to fill this gap, to be the glue that binds, preventing them from flying apart under their own rotational momentum. It's not like it's not observable though. We can see it warping space in the Hubble Deep Field images. But here's the clincher. The astronomers are looking for a particle, something with mass that is weakly interacting. They are currently shelling out $500 million a year on this effort, as well as taking up precious resources at CERN among other observatories. Let's approach this problem from a different point of view. Let's look at the other side of quantum theory for a differing perspective. The other side of the coin to matter, the wave function. I want you to think about our own galactic plane like a pond. Damn, that's a beautiful pond. And on that pond, gravity moves in waves on the surface. This is a great analogy because we know gravity moves and behaves as waves. From the LIGO experiments, we also know its effects travel at the speed of light from Einstein's general relativity. And much like a pond, gravity likes to orient on a plane. So if you drop one rock or star in this galactic pond, it makes a rush of ripples, spreading out in concentric circles of gravity that travel on forever and never truly fading. Pretty simple, right? Okay, let's drop 2 or 3, or maybe 10 stones in the water. If you do, you notice a weird effect when 2 of these radiating waves collide, much less 10 or 20 or 200 billion. These collisions will produce an effect called constructive wave interference, creating a peak wave in between the 2 solid bodies that is larger than the sum of either 2 waves. This principle of wave theory is used in noise-canceling headphones, but they use the opposite effect, deconstructive wave interference. If all bodies in space resonate with gravitational waves, whether it's the perpetual dance of neutron stars, massive black holes whipping stars around like a rabid tetherball player, or simple red dwarf stars wobbling under the stress of a nearby gas giant, or our own home star dancing to the rhythm of Jupiter, all celestial bodies resonate, whether in the Hertz range for pulsars or decades for our own sun. All the waves sent into the galactic plane have the chance to create these gravitational anomalies where nothing truly exists. A something where there is supposed to be nothing. The basic definition of dark matter. Gravity follows the inverse square law, just like light. Both travel at c, or the speed of light, 299,792,458 meters per second. And both can have constructive interference waves. We can see the effects warping space in the Hubble Deep Field. We know something has to be acting as the glue to the galactic structures. Why is this idea not even entertained? To go a step further, because gravity falls off like light inversely at a distance, it never truly goes away. Light from billions of years can reach us, so can gravitational waves. This is the solution to the cosmic galactic filaments we see comprised of billions of aligned galaxies. The reason most galaxies are aligned with their ecliptic to these super threads is because the resonance of the galactic collective spreads along this plane. We have dark matter and dark energy in a neat package. Until we have better detectors for gravitational waves, the search will be fruitless, and nothing will be gained in this field from chalkboard warriors. We need those who look outside the microcosm we live and think on large-scale, deep-time terms. Nikola Tesla told us, if you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. Thank you for watching Brandon Debunks the World. Remember to like, share, subscribe, and check us out on Patreon, or not. It's your call, no pressure. comment down below, give us some ideas for more shows, or just vent from the safety of your basement about how wrong I am with no repercussions or, real world consequences.